Okay, just going straight into it. The answer is on the board. I hope you can follow what's happening. The next section I want to do by just doing a document camera. I think it's useful to have a lot more color involved. So deal with it as it comes. Please notice that even here, when we are solving an equation, I'm making the left or one side of the equation always equal to a 0. That's essentially what you're going to have to remember. Try to keep it as organized as possible so you don't lose any communication marks. Otherwise, it is what it is. Let me try to summarize what's happening. I brought one side of the equation to the other so that it's a 0. The denominators were made into the same polynomial, which means the numerators would have to have changed. So x bracket x minus 4 comes from the first fraction. The 1 times x minus 2 is the second one. And then the negative 2, I don't have to do anything. It turned into a polynomial, which was factored. And when I factored, 2 of the binomials actually reduced and turned into a 1, leaving me with a much more simpler rational function to solve. Why would I want to do this big hunk when I could just deal with this small one? And so I just dealt with a small one. When is this tiny fraction equal to a 0? When x plus 1 equals a 0. So I have x plus 1. Using that, I plugged it into whichever function was easier for me, and it ended up with an answer of 2 over 15. The point of intersection is -1, 2 over 15. Okay. We can always refer back to this, or you can ask me questions on your own. What I want to focus your attention on is the next part. And this lesson is going to be very short. I'll just do one example with you, and you can look at all the other examples from the answer key I already posted online, or I will be posting very shortly. Please turn the page, and I'm going to change my video camera to this. All right. Pardon? Yeah, I'll show it to you afterwards. Okay. Here's the example. I am recording right now, right? Yeah, okay. Example 1. So here's your first inequality. I didn't give you an equation. I just want you to know what the question is asking when they put a rational function in an inequality. So here is a random rational function. You can see there are vertical asymptotes. You notice that it's a horizontal asymptote that's not a 0. And you remember what that might mean as a function in terms of degrees. Yes. So it could be x over x. It could be x squared over x squared. It means the numerator and denominator are the same degrees because of that. Anyways, look at the question. Solve. In other words, what's the x value when the function is greater than or equal to a 0? When is the curve greater than a 0? Go ahead, Yusuf.
You're in the equation or just like
Well, just describe it in your own words.
okay, so f of x, okay, so negative, so running bracket from negative infinity to are we
Oh, yep. So yeah, so what you're saying is basically this part. This part is greater than 0. Where else is it greater than 0? Mason? From 2, 0 up, and it goes up, 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 up. As long as it stays on this side, it is going to be greater than 0. And then it jumps down after the vertical asymptote until here. So I suppose the proper way of answering this question is f of x is greater than 0 when x belongs to, and we write all the intervals. It would be negative infinity, including -4, union 2, including a 2, but not including 5, because that's a vertical asymptote, u, and then including a 6 all the way to positive infinity. Yes. This one? It's a little e saying it belongs to the epsilon. Yeah. It's the little e that you write for domain and range. No, yeah. Well, the vertical asymptote is clearly between 4 and 6. I know that's a 5 right here.
Oh, right. Okay.
Yeah. You can, of course, write this in terms of just inequalities as well. But to follow through using this example to solve the harder questions, I need to ask you this question. Where are the boundaries? At what point do we see it goes from negative to positive and positive to negative? Where do you see the oranges start and finish? That, right? From the x-intercept, I go from positive and I turn into a negative. Where else do you see signs changing? Is that Nathan? Vertical asymptotes. What creates boundaries? X-intercepts and vertical asymptotes. Huh. Where else in our chapter 3 have we focused on x-intercepts and vertical asymptotes only? Ian? No, in chapter 3. Yeah. Maggie? The chart method. Remember when we were doing the chart, we wrote all the x-intercepts and all the vertical asymptotes here to see whether it's going to be a positive or negative or so on and so forth. And in essence, if you want to solve an inequality, you're not doing anything different. In fact, you don't have to sketch. You can solve this question by just doing the chart method. Let me demonstrate. Okay, we will do example 2. Just like before, let's bring everything to one side, make the other side equal to a 0, and turn it into a single fraction. So here we go. Everyone see it okay, right? Next. Anna? Oh, you're copying? Okay, never mind. I thought I saw something. Adam? Okay, yeah, so same denominator. It's good. Let me get to it. Okay. So the numerator I am going to simplify. That is 4 minus 2x plus a 6.
That's right.
Hmm?
You always move it to the left side, right?
I do. You don't have to. The answers will still be the same. if you want, you can move this entire fraction to the right side and make it equal, make it greater than a 0. Right now, this thing is less than a 0. If you bring it to the other side, you can make it greater than a 0 if you want.
But then that case, that's to answer the question. It's going to be going to actually the data or above it.
Yeah,
Right.
if you do that, yep. For me, I'm going to follow what I wrote. I'm looking for the situations when it's negative. If you brought everything to the other side, you looking for all the situations when it's positive.
That's, yeah. Get a question like that.
All right. What's next? So from here, as you can see, if you want to solve this question, it's nice to know what the graph might look like. Long story short, try calculating DIAC and your answer will sort of appear before you. So that's the domain. X belongs to any number, but X cannot be a 3. I. The, well, y-intercept, f of 0 is going to be 0, 0, 10 over 3, or negative 3. So this is my y-intercept, and this is my x-intercept. For inequalities, though, you will see that you actually don't need the y-intercept. We're not even going to sketch it. I'm writing it in there so that you know that it's still exactly the same as we've done before. Again, for inequalities, you will see that you don't need to calculate horizontal asymptote, but I'm going to do it anyways because it's what you've always been doing. Okay. Vertical asymptote. X is going to be a 3 because that agrees with our domain restriction. Horizontal asymptote, well, it's same degree. It's the same degree. So if you want, you can use a shortcut. What is it? Oh, good. Can't be 0. Jack, is that a question? Yeah, so it is negative 2 over 1. So you can just write y equals negative 2. Good. Again, notice I'm not going to write the plus minus yet. You're not going to use it. Okay. Vertical asymptote is 3, x-intercept is 5. There it is. A negative 2 is always a negative 2. X minus 5 can become a negative. X minus 3 can also be a negative. Minus, 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 plus, minus, plus, plus. Yes. Same answers. It should still be a negative, positive, and negative. Yes, you can.
Question, right?
I'm getting a lot of questions. Sorry, one at a time. Yep. For me, it just, there is no point. Me specifically, it makes my calculations easier. For me, if you had a negative 2x plus 10, I'd have to plug it in, multiply, and then add to see if it's positive or negative. Here, it's automatically negative, and here, I just have to do one subtraction. It makes my life easier. Absolutely. Yes. Okay, so now you're ready to graph, but do you need to graph? No. The question asked, hey, when is this less than a 0? We already figured out when it's less than a 0. In other words, I don't really care about this part. I only care about here and here. So, therefore, 4 over x minus 3 is going to be less than 2 when x belongs to negative infinity to 3, but not including, union 5 to infinity, but not including. You don't have to graph it. So part of the reason why I sort of force chart method on you when other classes apparently are not, I found out from Miss Jones's class that they don't. It's the same stuff over and over and over again. It's just a matter of how you want to use it and what it tells you. Beta? Well, so again, it's basically anything that can become a negative. And so this -2 will change the sign. And so I left it in there. Yes? Sorry, I missed that last part. Is there any chance? Yes, yes. No, because this context, we have set it to equal a 0. So we are looking for when it is in fact a positive or negative, right? Because if this was a horizontal asymptote and it did one of these, it's still crossed and it still remains a positive. We don't care if it does one of these, right? If it goes underneath, then we'll have another x-intercept. Oh. And it will solve that for us. So everyone, that's it. Solving equations, solving inequalities, you're still making one side equal to a 0. And then you're going through the motions of DIAC to either find the x value or to find the positive or negative intervals. That's it. If you take a look at our right space, this is the previous week class, but I'm going to put up the same thing. You will see a new post for 3.4 and 3.5. The 3.4, if you click on it, the PDF is already there, ready for you. Every single example I have solved. The one we just did is right here. And example 3, the answers are here. In example 4, I don't have enough space, so you'll see it on another separate piece of paper. You will see from my answer key that the biggest part of the answer, the hardest or the most annoying part of the answer, is going to be the rational expressions portion where you're making 2 fractions equal to 1. Once that is established, DIAC is again the same stuff you've seen over and over and over again. Before you leave today, I would like to push you to try examples 3 and 4 in class and just double check with the answers that I'm going to post on your Brightspace. Question. Yes, absolutely. Any other questions before we sort of go? Okay, let's get started. Get some practice in before you leave today.